stiffness of the spring, I mean not mass, per spring, the stiffness of the spring and its mass makes a difference, okay?
With the spring, what doesn't make a difference?
With a spring, what doesn't make a difference?
Yeah, because like with mass and like how high you start with the.
Sit.
Maybe the spring itself.
It's okay. I may have this backwards or upside down. I have to look at it, but I think that's right. Okay. Mass divided by spring constant. Okay. The K is how stiff it is. But the thing that seems not to really make a difference on the spring, how far you stretch it down,
Okay.
it's going to be roughly the same. Okay? And this period right here is what is able to kind of help you see it as simple harmonic motion. You're getting a time for a repeated cycle. Okay? Now remember what I said a minute ago, keep that thought. Let's use it. Okay? I drop this big mass. I put a marker up here, and it's going up and down. And I have a piece of paper. What type of shape is this going to make? A line. What was that going to make? Okay? And if I have that happening, okay? If I have that line, and I take a piece of paper, and I either drag it in front of that marker on the spring, or I have this piece of paper underneath here where that pin's riding, and I drag it this way. What's it going to do? There's a line, and it drags by, right? What do we get?
A wave.
A wave. Every wave starts as a result of simple harmonic motion, some type of vibration. Makes sense?
What were those equations?
That is a square root. This is, right here, the period of a spring. This is the period of a pendulum.
The one that LNG is putting on?
Because what made a difference? Length and gravity. What made a difference? Mass, stiffness of the spring. And the reason we have 2 pi, if you were going to get the circumference of a circle, what's the equation for the circumference of a circle? 2 pi r. A cycle is like a circle. It comes back to where it started, 2 pi. Okay, are we connecting dots? Kind of make a little bit of sense. Okay, good. All right, one last thing I want to show you with this. We tried going big weight. Let's go small weight. This is 1/4 of where we started. This is 50 grams. We started with 200, and it's 1/10 of what we just had on there a second ago. So just for kicks, okay, you want to go down with smaller mass, what happens? Ready? 1, 2, 3, go. 1, 2, 3. Stop. Okay, so you decrease the mass, what happened to the period? It's smaller. You increase the mass, the period gets bigger. Okay. Now another really cool thing. This is an important thing in a very, very, very important thing with waves and simple harmonic motion and all the stuff we're dealing with. But there's a really important relationship here. Now we said the period, amount of time for complete cycles, right? So the way of thinking of that is time per cycle. Or what's time measured in?
Seconds.
Seconds. For how many cycles for one period? 1 cycle, right?